Here we are. We are live again with the very last presentation from Mark Talluto. So let me just have a look, see if you're joining me. Oh, yes, you are. Look, there's 41 of you dedicated people back again and about to find out why everything we do is a database application. So if you could just wave at us in the channel, just confirm that you can see and hear both me and Mark. I'll just wait for some people to post there to say yes. That sounds great. We are here. Yep, Kelly is first in again. Okay. There we are, and Brian, and another Brian, two Brians. Jim and Sandy and Dave. Yep, we're all good. Okay, it is all yours, Mark. Take it away.
Great, thanks. So, hi, I'm Mark. I'm from Canola Software, and I thought I would start my video with a live view of the office. This was going to be in the video itself, and decided to do it live. So when you see it mentioned in the video, just we're not gonna pretend it's not there. So I thought it'd be fun. Kevin and I discussed doing this, and other people doing it as well. It'd be fun to see what people's workspaces look like. So I'm just going to quickly just kind of maneuver through. This is at the front door, and I'm walking backwards. And here you can see our main area. This is where we write most of our code. As we go around in that room back there, I hang out back there most of the time. That's the space I live in. And as we spin around, this is our kitchen area. This is where we're going to be watching the video. So everyone will be joining us in just a moment. And I've already got on the website loaded. So from here, let's get to the presentation. I'll start the video now.
Hi, my name is Mark Talluto, and welcome to Everything We Use is a Database Application. I am the founder of Canola Software. Now, the title of my presentation is probably not 100% accurate, but just about every time we use an app on our phone or computer, we are accessing data through an application. It is almost magical how we can set up an Uber ride, buy order-to-made coffee, or catch up with friends in social media. In every instance, we are manipulating data with ease, at least when things are going our way, or rather when the developer did a great job. This presentation is about database applications. It contains both business and technical information. Let's go through an outline of this presentation. We are going to take a quick peek inside Canola Studio. We will be talking about what a database app is, and why making a database application should be on your to-do list. In the context of our Nurse Notes app, we will discuss business and technology considerations, demonstrate the app's features, and we will go over what I consider to be the problem with database apps, specifically difficult network conditions. Your takeaway will be a working database app that we call Contacts. You'll be able to tear it apart, rebuild it, and reuse it for other projects. It is a fully working and network-connected app. Canola has developed a set of libraries we call CassieDB. We have connected the Contacts app to our cloud environment called LiveCloud. The Contacts app is already connected to LiveCloud for your convenience. But you can modify the database calls to work with any database you want. We'll do a walkthrough of the Contacts app, and we'll take a quick look at the code. And at the end, we'll have some time after the presentation to take any questions you might have. A database application is software that allows you to do one or more of these actions on data. It is referred to as CRUD. No, not the stuff on the bottom of your shoe. We are talking about read, write, update, and delete, all actions that apply to data. This may sound very familiar to those of you that work with databases. If so, you may already be a database application developer. But if not, I'm hoping that you gain an interest in getting started yourself. You might be thinking that databases are hard to work with, or that they are boring. Database apps may conjure up images like these. Initial database applications were very vertical in nature. They may appear to be dull and underappreciated, but for the people that rely on them, they serve a very important purpose. The promise from today's apps is real-time access to data, beautiful front ends that hide the complexity of all the data manipulation taking place. In this example, we have a desktop app on the left and a mobile device on the right. They are both connected to the cloud, and as data is entered into the desktop app, you will see that the data is magically available on the mobile app. The demo then shows that the mobile app can also manipulate data. As you have guessed, the changes are now updating on the desktop side. This is what users of our apps are expecting. They want their data everywhere, and they want to access the data from any device. If you are thinking, nope, no sir, not going to do this, let me put your mind at ease. With today's modern tools, you can do this. LiveCode is the perfect platform to write these types of apps. In a moment, you will see that we have done this successfully, and we did it in LiveCode. Today, the range of database applications are wide and appeal to horizontal as well as vertical markets. Some well-known examples would be Facebook, Slack, Twitter, Pinterest, and Instagram. Now, databases appear not only in social media, you will find them in almost every category. Just about every software category has apps that work with data. These range from games, finance, business, medical, lifestyle, productivity, travel, utilities, and social media. Yeah, some of these cross over a little, but you get the gist of it. The breadth of options available should provide some tantalizing appeal to every developer. With so many options to choose from, how do we decide what to make? We have made many apps over the years. Until the last few years, none of them were database apps. Some were retail apps that have a traditional buy once sales model. We have made software as a service packages as well. We have experience making $20, $50, $1,700, and $60,000 apps. We have sold our apps in stores, through distributors, and direct to customers. Of note, all of these apps shared some qualities in common. Over their lifespans, they took about the same time to develop, and the customers always demanded best-in-class support. Each app required us to work hard. The key point here is that we eventually learned how to work smart. There are many business decisions involved in choosing your next killer app. What you choose to spend your time on matters. Picking a subject matter that interests you is easy. Making it profitable, if that is what you desire, requires more consideration. Here are some ways to help you. This is not an exhaustive list or a surefire method for success, but it is part of our process for deciding what to work on. I like to look at the present and future career outlook as one of the ways in deciding where to focus. I have found some good insight from top jobs lists that are put out each year by various financial sources. Looking at US News 2017's top jobs list, we can see that 2 of the 25 jobs are related to mathematics. 2 are technical in nature, and the rest are medical. Consider how your customer will fund your service. Look for areas where the government forms mandates for a given task or event to be modernized with technology. Mandates require your customer to buy a product in your category. It is preferable to focus on software that lends well to recurring income. Easy now. I can almost feel the heat rising through my monitor as I say that. As consumers of technology, we prefer to pay once, use forever form of sales. But did you know that most enterprise software actually lends itself better to the software as a service model? In our experience, Our customers actually asked us to build them this way. This type of customer is looking for regular software updates and technical support to be included. They sometimes call these long-term maintenance packages. Wrapping this up into a properly priced service, not product, will set you on the road to a great adventure. Why not call it a product? Well, because customers buy products outright, but these same customers lease or rent services. And the goal of software as a service from the customer's perspective is to lower capital investment and allow the customer to try a technology before committing to a long-term relationship. If the service does not properly meet their needs, they are free to use another one. So as you can see, this works out well for everyone. From our research, we found the money is there to fund such projects. We have analyzed this information and determined that developing for the medical field would be stable. And it has been very stable. In fact, it has been growing over the last 12 years. The quest to be a stable company eventually directed us to look for multiple veins of income. In our case, we took our knowledge of vision testing in the eye doctor market and looked for other areas where we could capitalize on our code base. It turns out there were a number of markets that have been ignored by our competitors. Were they missing it because they are still focused on the doctor market? Did they already look at other markets only to conclude that the market was not profitable? Without having corporate spies, we may never know. So we decided which of the new markets looked to have the widest customer base. We also looked for financial security. We learned that the government mandates that students be tested for vision testing and hearing. Plus, there are requirements for school districts to move from paper to digital record keeping. We already have school districts using our vision testing product that was made for doctors. Listening to our users pointed us in the right direction. Our school nurses were telling us that they needed a way to auto-record the vision screenings and transfer the data to their student information system. And they wanted audiometry features. They were also asking for yearly maintenance contracts. Wait a minute, schools are asking for software as a service model? We can take what we know and make a solid pivot. It didn't take long to connect the dots. So we made Nurse Notes. Let's talk tech. We are going to follow the experiences the passengers in this car have during their drive to the countryside. Let's see how things go. Right now, we are at the house getting ready to leave. Both passengers are connected to the Wi-Fi in the house. Life is good. The apps are living up to everyone's expectations. The problem is that the speed and reliability of a home network can only go so far. And as the car drives away, the mobile devices in the car switch over to a mobile connection. Luckily for them, their nearest tower is just blocks away. The connection remains strong, and both passengers are happy. The car is now going through the city, and those tall buildings are causing some interference. One of the passengers has a sad face. The app they are using is hanging. It seems to be dealing with the rough connection poorly. The other passenger, on the other hand, has not even noticed that the data is getting shaky. Let's ponder that in a moment. For now, let's just enjoy the cityscape. Our travelers are driving through the mountains. Unfortunately, both passengers have lost their connection. Both of the passengers realize the connection is broken, and the sad passenger is now getting frustrated. As they check out each other's app and see that they are not having the same experience, frustration turns to anger. Now might be a good time to look out the window and cool off. Yay, we have finally reached the countryside. The mobile connection is now stable. Our happy passenger has had the most enjoyable trip. Productivity for her was high. She is thinking of posting on all of her favorite social media hangouts about her experience. Surely this will only benefit the company that made that app. On the other hand, our frustrated passenger has nothing good to say about his app. He is also thinking of posting his thoughts about his experience. I am sure glad that I am not the developer of that app. Hey, look on the bright side, Mr. Grumpy. We arrived safely at our destination. Like all aspects of development, there are many things we must consider. Database apps are no different. I decided to focus on this particular problem because it is going to affect all DB app developers. All applications that rely on a network share this common enemy. There are many factors that affect our networking performance that are dependent on various areas within the network itself, from the technology of the device used, the local environment the signals will travel through, the fundamental physics behind wireless transmission, and more. Some of these cannot be avoided, and measures must be taken to try to minimize the negative impact. This is most likely an issue with wireless connections, but it can happen to wired connections as well. Either way, we cannot ignore that this will eventually happen to our users. Let's give our users happy faces by properly dealing with this problem. As we saw, some software gives up, and that may be reasonable depending on the app. Some types of apps are better able to survive this situation than others. I have used apps that simply tell me that the connection is down. They hang there waiting for the connection to come back. You cannot interact with this category of software. When the internet is available, the app will continue working. Under certain circumstances, the software may take you back to a state before the connection is made and require you to initiate the connection once again. This is most commonly seen in multiplayer games where people are interacting in a game together. You'll see this in off-site file backup solutions. This is also an issue that plagues apps that incorporate some form of communication. Real-time communication cannot exist in an app that does not have a network. This solution will work for a good majority of apps. This is not to say that it will work with all apps. The main thing is to embrace the power of the local device. Do all of your CRUD calls locally. If the calls are CUD in nature, meaning creating, updating, deleting data, then execute them locally first. Follow that up by executing them to the cloud, where you think. If you are in a no network environment, then cache the cloud portions. You will want to check for the internet occasionally and attempt to flush your cache to the cloud. It is very important to keep the order of those transactions to maintain consistency with the user's expectations. Music streaming apps, as one example, use this solution. They basically pre-cache data while the connection is active. Should the network hiccup, they can rely on the cache data to keep the experience going, and the beat goes on. Apps that record data can also work well with this solution. Apps that allow the user to consume data should fit nicely here as well. If the execution is just right, the user may not even notice the breaking connection. LiveCode development sits well with making applications that are designed this way. It doesn't really matter which tech stack you have chosen. We should always aim for this model whenever possible. Need more time to get this straight? Don't worry. When we walk through the apps, I will mention what is happening. Also, you will soon have access to an app that already does all this in simple to read code. Let's have a brief look at nurse notes. Security is a big deal when dealing with personal data. Nurse notes works with student data. We are connected to a development database that has fictional data for this presentation. Nurse Notes holds student data for the whole school district. It contains data about the students, teachers, and schools. We are going to do a simple search using the drop-downs provided here. We will pick a school, then a teacher, and press the search button. This will generate a class roster for this teacher. The data has to be available at all times, even if the network goes down, which does happen, or if the nurse is using the software in a dead zone. All newly created data and data updates must also be resilient to difficult networking conditions. This is a challenging environment to support. Most school nurses are required to work under varying conditions based on their location at any given time. They sometimes work out of an office where their laptop has a hardwire connection. Sometimes they work out of the library on Wi-Fi. Sometimes they are required to work in the school gym where neither a hardwire or Wi-Fi connection is available. I am currently disconnected from the internet for this walkthrough, yet everything I am doing that is meant to go to the cloud is safely being stored locally on my computer. This one feature is a key selling point for Nurse Notes. Other products that hold student data have the requirement of being connected to the internet full-time for them to work. When our customers learn that the system will work offline without interruption, we are demonstrating that we understand their difficult working conditions. Clicking on a student's name will reveal the student's basic information, along with the most recent screening data. This tab allows us to switch between their vision and hearing results. From there, we can view historical data on their screenings. Below their testing scores is an area where the nurse can store personalized notes on the screening. All data we see here is stored locally on the nurse's computer. This allows the nurse to access data when disconnected from the internet. This works well for this particular app. Data that is added to the record is immediately stored in the cloud as well. Should the nurse be offline, the data to be stored is automatically caught by the database and stored encrypted locally until the nurse is back online. We set the database to automatically check for internet access every 60 seconds. If we are online, our database will flush the cache to the cloud while maintaining the order in which the data is to be written. The analytics screen allows the nurse to visualize their data. From here, we can focus on the school year that we want to view. We can pick the type of report, and we can select the metric to be used for display. In this case, we'll leave it on student. The options available are based on the report selected. We can zoom into the data for a closer look. We are using the browser widget to create this view. In this case, we're using HighCharts in the browser widget. The JavaScript used to drive the library is modified in LiveCode. We take our data from the database already in array format and massage it into a JavaScript object. Clicking on a bar in the widget generates an event that calls a JavaScript handler. Inside the JavaScript handler, we can call a handler in LiveCode and pass data into it. In short, we have tight integration between the widget, JavaScript, and the database. The final part of this application I want to show you is the Print Center. Traditionally, the nurses generate queries manually to access data in the student information system. This requires knowledge of SQL in most cases. Thus, when the queries get difficult, they have to refer to IT or someone dedicated to understanding the query language needed to get at the data. Knowing our market, we decided to hide the complexity of generating a query from the nurse by making an easy-to-use visual query builder. The nurse never sees the query under the hood. Let's select a category, in this case vision, and I'll pick a document, the class roster summary. Now I only want to see filtered results for this particular summary, which will provide me these following options. In this case, I want to see all of those students that have been referred. From here, we have a date range that we can select, and I'll leave this as it is right now. Let's pick a school, and we're going to search for all the teachers. We're going to select them all below, add them to our print queue, and press the print button. From here, we can see that 26 teachers were affected by this, but only one student was referred. So we'll have a total page count of 1. From here, we can press the print button which brings up the standard Windows or Mac print dialog. In this case, I'll just open this in preview. And from here, we can see the student and their test results. This concludes our demo of Nurse Notes. Let's take a look at the Contacts app we have created for you. It is a familiar and simple contact management app, and this app follows the model we discussed earlier. All the data in this app is stored locally. All reads are done on local data. Thus, the app maintains its usefulness when there is no internet connectivity. Clicking on a person shows their contact information. Both the update and delete buttons work offline and online. The cancel button will return you to the list of contacts. This is a 2-card stack. It utilizes 2 behaviors, 1 for each card. Thus, this is a version control friendly style app. Let's take a quick peek at that. As you can see, we have a card named Main and New Edit. When we're looking at a contact up close, we're in the New Edit card. When we click Cancel, we'll go back to the Main card. Here you can tell that there is no native code in any of these controls, but we are using behaviors located here and here to make this a version control friendly style app. Let's dive in a little closer. We will press the plus button and generate a new contact. This will make a new record. Next, I will press the Create button. The data was stored locally and was then synced to the cloud. I'm going to click on my contact name and view the data. We just performed a local read on the record containing my data and presented it in the fields. From here, we will delete my record by pressing the Delete button. My record is deleted locally and deleted on the cloud using 2 separate calls. At any point, we can press the Sync button to perform a sync. This will ensure that we have all the latest edits and additions in the Contacts app. Okay, let's get into some code and see how these various database calls work. So I have a breakpoint in the code that's going to pop up when we click on any one of these contacts. So if I click this individual here, this is going to break us in the behavior that contains this particular handler, edit contact. So what we're looking at is this is a variable tool we have created. So it'll allow us to watch as an array is being made in real time. So I'm going to step over, and I'm taking this value, which is the record ID, to this individual's contact information, and that's being placed into to a variable for T input. So let's continue. So we specified the record ID and we specified the table name, and we named this table users. And now we need to know where we're going to do the read, local or cloud. So we're going to define it as local. And then we're going to do the read, and it's going to put it into this variable here. I'm just going to go right over that. And we'll take a look at that variable. So this is the record ID. This is some metadata to the record. And here's the actual data that is inputted in for this individual. Their date of birth, email, first name, last name, and their phone number is now in this global variable array. So it's that simple for the read. Okay, why don't we let the software then finish the read and build the display or the view for this particular person's contact. So I'm just going to let this run. And here we have the data that matches what's in our database, which is fine. Okay, let's take a look at the delete code. So I put a breakpoint in for delete, and this is in the other behavior of the two. So I'm going to press the delete button, and this is the delete code right here. So the very first thing we need to do is take a look at our gcontact variable. And you've seen this a moment ago. This is the array that is of the last person we looked at. And what we're trying to do is get this record ID. So if we put the keys of gcontact A into T record ID, we're going to get this value. Let's take a look. And there it is. So we're going to build our T input variable. It's empty right now. I'm just going to walk through this. Again, you know, these are the basics you need for accessing a record. We need a record ID. We need to know what table we're talking to and whether or not it's local or cloud. So I'm just going to skip right over those, and we'll take a look at our array. So we have a record ID, we have the table users, and we know it's a local call. And we're going to call delete. And this will delete the record locally. Now we're just going to modify the target one more time and move the cloud into position. And if we refresh, we'll see it's a cloud call now. And we're going to call the delete once again. But this time it'll delete the record on the cloud. And then from here, we're just going to take ourselves right back to the main screen and draw the list of the contacts with this individual no longer with us. So I'm going to press the run button for that. And here we are. And he's gone. Okay, let's take a look at a record. In this case, we'll look at Kobe Bryant. And really good friend of mine. And I noticed that we did enter in his information correctly here. So we're going to update this record so he can be your friend too. And we were kind of sneaky. Really, it's just Lakers people. Yeah, there's the update. So what we're going to do is press the update button, and again, I put a breakpoint in for us. And you're going to see this is all the same. You know, the update, delete, read, and you're building the array the same way every time. So just to be clear, we're going to take a look at our T record ID, and this is the record ID for Kobe. And what we're going to do next is we're going to start building our T input variable. So let's get that right there, and we'll go over that and look at that. All very familiar. Our record ID, our table name, and we're talking to the local database with this call. Now, what we need to do that's a little different than the other calls is we need to collect the data that we're going to be updating. And this is a very, simple way to do this. You can auto collect this data in a repeat, but we're just going to keep this super simple. So I'm going to open this up a little wider so we can see all of this. And all we're really doing here is grabbing the fields of the record, and we're going to put that into our array. And these are the keys of our array. So these match. So let's just go over and we'll take a look at our T input array now. So we added in the data for the keys. Now you don't have to enter, collect all the data. You could have collected any one of them. If you had a routine to figure it out what was updated, you could just update one key or all of them. It doesn't matter. And then we're going to call the update command. So that's pretty simple. And now that data has been updated locally. Now we want to get that data up into the cloud. And so what we're going to do is we're going to do a sync up. We're going to walk into this handler. This is not an actual database call, it's just another handler that we call a database. And we're going to pass that record ID to the sync up handler. So let's go in there and see how sync works. So we pass that record ID in P record ID. And we're going to be building a new input variable. And there's that record ID. And we need to know what table. So users, and we're going to specify that this is the source data is coming from the local side, as can be seen here. And we're going to tell the sync how we want to deal with collisions. So we're going to put a false into their preserved target. That means if it sees it, it's going to overwrite it. The local is the master. And then we're going to call this particular sync is called sync partial, because we're sending just a handful of records, or one record in this case. If you know the record IDs, this is a great way to do it. And now we're going to go over the sync partial, and we'll zoom back out. And that is an update, both local and cloud. Okay, so let's take a look at the create code. So first we're going to go into the section where we create a contact, and populate this with my data again, 1-2-1990 this time, and there's my phone number. Yep, that's it right there. You can get me here though. Okay, so I'm going to press the create button, and here we are, breakpoint, how convenient. And this code right here is just going to validate that we've populated the fields. And if we haven't, then at least the ones we determined to be essential. And if they're not populated, then we're going to go into that if then, but we're not doing that. So now we're going to build our array. And you might remember that this is just like the update. I mean, here we are capturing the data in the fields and building our variable. So we'll just walk right over those, and we'll take a look at those here because we've been doing that, and I think that helps solidify what's happening here. So there's the data from the field in our T input array. Come back in again. So we're going to specify the table name again. We're getting good at that. Users. And we're going to just specify where we're talking, and we are going to be going local. And we're going to create this record locally, as we said. So we're doing all of our CUDs, our CUDs from the CRUD, the create, the updates and deletes immediately locally. And the reads, for that matter, too. So let's do that create, because this doesn't require internet to do this. And the user now has their data. They're going to see it regardless of the internet connection. It's available to them. And that always feels good to have that level of success. Now, when we create a record, we get something in return. This is a function. And in this case, we're getting the record ID of the record that was recently created. And as you may have guessed, we're going to pass that to the sync, and we're going to sync that stuff right back up, just as we did before. So we'll go take a look again. So here's our T input array for sync. Very familiar, record ID, table name, and the source is local. And there it is. And then we're going to keep on going. We're going to set our settings, preserve target false and source local. And then we're going to allow that to sync right on up there, and away it went. And I'm just going to let the software continue to run the rest of the way. And we'll zoom back out. And I've been added. There's my data. It's as easy as that. Okay, the process of getting the contacts app is as follows. We're going to go to the livecloud.io site, and we're going to download the LiveCloud Manager. We're going to create a free account. We're going to export our contacts app from the projects section of LCM, and then you can just run the contacts app in LiveCode. Okay, so here we are at the livecloud.io site, and all we have to do is click the Get Started button and scroll down and select the version that matches your platform. Now, quick note, the Linux version is a little shy to come out and play right now. We are working on its self-esteem and should have it out soon. So for the time being, it's Mac and Windows only. Okay, so now we're at the main screen for LiveCloud Manager, and we're going to export the Contacts app. So you just click on this plus right here, and we're going to export this Contacts app by just selecting it. And we need to create the project and tell it where we want to go. So I'm going to put it on my desktop and just press choose. You'll get this dialog when you know you're done. Click OK and cancel to get back into LiveCloud Manager. So the next step is we're going to leave this running because I'm going to show you the interaction between having this open and having the app open in LiveCode itself. So let's open this folder, and I'm just going to drag the Contacts app onto one of my LiveCodes. All right. So here's the app itself. We've already seen it, but I want to show you the relationship between how you can use the app and verify that the data is doing what you're expecting it to do. So coming back to LCM for a brief moment, this is our project contacts, and these are the tables. Every project will have a live cache table. This is something that we make for you, and this is what manages your auto support for when you go offline. Basically, this handles all of that. It caches all your cloud calls for you, and it flushes it for you. So we make it available so you can see it, and you can see that data is being cached locally and whatnot. So we're going to focus on the users table because this is what allows you to see the data that's in your contacts app. And we're going to just refresh this. So this did a quick cloud call and sync the data down here to the manager. And you can see our sample data is here. And this will match perfectly what is here. Okay, so let's take a look at my record. And we're just going to right click on my record and we're going to delete it. So yes, that's gone. And you'll see that I'm here, but when we press the sync button, I'm not. So there's a relationship there of you being able to edit your data over here in the manager and seeing it in your app. Conversely, we can go back in and just really quickly, put me back in. And there I am here. And if I refresh here, there I am back in the database on the cloud. We can even edit the data here. And we can sync and come look at my record, and it's been updated. Keeping in mind that all the calls are local. Now you can have your sync run automatically as often as you like so that the user doesn't have to press the sync button. It really just depends on the app and the flavor you want, but you have this code here to look at. You can always send it in time. On top of being able to see your data as the cloud represents it, you can also take a look at your data locally, because inside of this folder, you have a folder for CassDB and you have a database folder, and these are your cached records for this project. So this would be your users table, and this is your live cache table. So this can be handy to see what you see locally or what the app sees locally. So we're going to press the local button. And now we're looking at our data as this app sees it. Not what's in the cloud, but what's stored locally to the app. And of course, because they've been kept in sync, they'll match. Sometimes when you're troubleshooting your app and you want to verify that it's behaving as you expect, this is one way to allow you to see the data on the local side. Again, you can manipulate it just like you can in the cloud, and you can even push this data up to the cloud with this button here. You're in full control. So I threw out a lot of compressed information. I hope you found something in there that's useful to you. I'd love to take any questions that you have for me at this time. Thank you.
Hi guys, so we're back live again, and I think Mark is, there we are. Okay, Mark, you're back. You're back on.
So how much?
You're there. You're there.
Yeah,
you're back live with the actual video now, with the actual webinar.
Okay, so the video is still going?
No, it's finished.
Oh, okay.
You have some questions as well.
Okay. Yeah, sure. You're welcome. So yeah, thanks, Jim. Okay, so Dan, you could modify this app to work with the MySQL database for sure. You could modify it to work with Couch. It could work with any database. You would just take those CRUD calls and just delete them appropriately, the portions you don't want, and then exchange them with the actual database commands of your choice. So the cache table is Clarence. The cache table is the automatic caching of records that fail when they're trying to be uploaded to the cloud. It's an automatic internal thing. So you would be able to see that in your LCM, your Live Cloud Manager. So and the video goes over that part right there, so you'll be able to see that there as well. You're welcome, Sandy. Thanks for coming. So Ralph. Okay, so it's not a direct DB connection. Everything goes through a PHP middleman with an Apache setup. So it's a LAMP setup on a DigitalOcean droplet, and then after that, on the other side is a LiveCode server that we built that processes everything that is going in and out of the database. So it's secure because you can't talk to it directly. You have to go through the PHP, and everything's encrypted. And if the service can't decrypt the message, then it's not a valid message and it gets deleted. So injections can't happen. Hi, Herman. Thanks a bunch. Appreciate that. Great. Did I miss any questions?
I don't think so. Let me just scroll back down a second. No, I was just having a bit of an issue with the video at the end, but it's okay. Evidently, everybody else wasn't, so that's good.
Well, we're watching it over here, and it's still going. So that's why I thought it was still going for everybody. So I'm sorry.
I know, because you had it playing.
It was way long there.
Yeah.
Because it's still playing on this end. Let's see. Ralph, go directly to the LC server via HA. Please explain why you used a PHP middleman. Oh, okay. So we're not using LiveCode server. It's a server that we built ourselves. And so therefore we're using PHP, but we could have used LiveCode server to be the gateway between us and the database. But at the time, we got working on it and we decided on PHP. So, which is fine, but anything could have worked for sure. So Clarence, is the behavior handled in a card or a stack? So there are two behaviors to the Contacts app, and they are in their own stacks at the stack script level, and they're text only. So you can actually open those behaviors in the text editor and actually read the code there. Arthur, how many schools using the Notes app? It's a brand new service, so I don't know the school count. That's a really good question. We're in 4 districts live right now, and 2 are very large districts, and 1 is good size, and then we have a smaller district. So amount of schools, maybe counting, I guess, maybe 100 schools would be a rough idea. And then we have another 10 districts that are beta testing it right now. So we're the sales cycle is very long when you sell to schools, school districts. So it's about a year. And so we're working on the sales now for purchases next year. Okay, let's see. Dirk, is that something we can install in our own servers? We hope to one day. We don't have it ready yet for your own server, but that is a plan for us to make it so that you can do that. So for now, we are just hosting it because it does make it easy for a good majority of the users who may not be technically inclined or interested in doing that. But at some point, we want to make it so that if you wanted to do it, you could. There's no technical reason why not. Right now, we're not even billing. So we've got a few things to finish up there before we even get there. So Ralph, so there are no security issues with using LC server, as long as it's HTTPS. Yeah, and that wasn't a reason for not choosing LC server. It's just I didn't know it at the time, and I know more PHP, and so that's just where we ended up. Dan, is the data on the app stored in files or in a local DB? Okay, so both locally and in the cloud, these are RAM-based systems, but they all cache the data local to them. So if it's a cloud call and you write to the cloud, it's stored in RAM in the LiveCode instance that we've built, but it's also cached to disk in the event that the server needs to be rebooted. Thanks, Arthur. Appreciate that. And thanks again, Ralph. That's awesome. All the data, Clarence, is encrypted, both locally and in the cloud. The portions that are on disk. The data that's in memory is not, so that it can be queried. And the data that's transmitted is encrypted as well. Thanks, Dirk.
Okay, that's cool. Are we perhaps reaching the end of all the questions here? Shall we just we'll just give them another minute or two, shall we?
Sure.
But I think we're there. That was a great effort there. Thank you, Mark. I know that was a lot of work for you, so thank you very much.
No, thanks, Heather, for helping me get it through. Thanks, guys. That's awesome.
Okay. So that is the end of day 4. Day 4 of LiveCode Global has ended. So here we are, and that was some great talks and some great speakers again. And yeah, I mean, it blows me away every time. These people, they come and they show us all this stuff. It's amazing. So do come back in a month. The next one is, goodness me. Now then, do you know I've been looking at this schedule all day, and I have now forgotten the date of the next one. The next one is on October the 19th. October the 19th, we're back to do it all again. Elena will have more beginners training. Fadila Iskandar is going to come and talk about her work in Malaysia. We've got the monthly report. We've got, so much good stuff. So come back in October and we'll see you all again. Thank you so much for coming. Bye-bye.